Hello everybody, this is a video lesson for section 7.1. Starts on page 458 in your book, and this will go along with homework number 18, which is going to be due on Thursday, November the 16th. For the first example, we'll just do a review of radicals and exactly how they work. Before we get started, I'd like to talk about the parts of a radical, and we'll do that with this radical up here in the top corner that I'm getting ready to write. Okay, so basically we've got three parts of the radical. There's the radical bar, which is the bar, obviously in the middle, and then you've got two variables here. You've got an x and a y. The x we call the index of the radical, so this x here is called the index. Typically, when you see a radical like example at 1a there, which is the square root of 25, the index typically won't be written. So if there's not an index written, we assume it's a 2 or a second root, which we shorten to call a square root. And then the y in this is called the radicand. Radicand, of course, if I could spell it, that would help. Okay, so we've got the index and the radicand, and then of course there's the radical bar. So for the first example, again, the square root or the second root of 25, we're just looking for what we can multiply by itself to get 25. Of course, that's 5 times 5, so the square root of 25 is just 5. The cube root of negative 27, we need what times what times what, gives us negative 27. Of course, that's going to be negative 3. 3 times 3 is 9, 9 times 3 is 27. The sixth root of 64, literally it's what to the sixth power is equal to 64. The sixth root of 64 is 2. And the last one there is the negative square root of 4. Square root of 4 is just 2. So the negative square root of 4 is going to be negative 2. You may want to look up your particular calculator some directions for inserting indexes so that you can use your calculator to help you with some of those higher powered or higher indexed radicals. Okay, here's your chance to try some, so go ahead and pause the video right now. Give those 4 problems a try, and then once you resume the video, I will put the answers up. Alright, so there are the answers to those: 4, negative 2, 2, and negative 5. Alright, for these we'll talk about roots of variable expressions. Believe it or not, these are actually a little bit easier to do because there's a shortcut for it, but I'll show you the reasoning for the shortcut first, and then I'll show you how to do the shortcut. So the square root of x squared, what times what, or what squared is x squared? Well, x squared is x squared, so the square root of x squared is just x. B is x to the square root of x to the 22nd. So again, what, and I'll use a different variable so it's a little less confusing. So if I have a number and I raise that to the second power and I get x to the 22nd. Well, the rule for power to a power is to multiply, right? So what times 2 is 22? Well, it's 11. So that a inside of there is actually x to the 11th. X to the 11th to the second is x to the 22nd. So the square root of x to the 22nd is just x to the 11th. Fourth root of w to the 40. So again, if I have a number in here that's raised to the 4th power and I get w to the 40th, then that number in there must be w to the 10th. W to the 10th to the 4th is w to the 40th. You see the shortcut yet? Let's go ahead and do a couple more here. Cube root of t to the 18th. Again, this is the last one I'll do this explanation with. What to the 3rd power is t to the 18th? Well, that in there must be t to the 6th. 6 times 3 is 18, right? Last one, 5th root of x to the 30th is x to the 6th. Shortcut. You take the power of the radicand and divide it by the index, and that gives you the power of your answer. Alright, again, pause the video. The answers will be coming up shortly, so make sure you pause the video here, try those 5, and then I'll show you the answers. Alright, there's the answers. I hope you paused the video, otherwise you're seeing these right now and you haven't done them yet. So there's the answers. Again, just take the exponent, divide it by the index, and that'll give you the exponent of your answer. Alright, the product rule for radicals says if you have a product inside there, that you do something special. So example A is the square root of 4x. That's the square root of 4 times the square root of x. That's what the product rule says. We can break it down into its parts and take the square root of each part. So the square root of 4 is 2. The square root of x we can't actually do anything with. So that's going to simplify down to 2 times the square root of x. Next one, square root of 3 times the square root of y to the 8th. This time I can't take the square root of 3, but I can take the square root of y to the 8th. It'll be y to the 4th. So that's y to the 4th times the square root of 3. By the way, anytime we simplify a part of a radical, we always write the simplified part in front and then write what's left under the radical second. Next one, cube root of 125 times the cube root of x squared. Oops, x squared. Cube root of 125 is 5, right? 5 times 5 is 25. 25 times 5 is 125, so that's 5. And then times the cube root of x squared. We can't take the cube root of x squared. All right. Patterns say I have to give you a few to try, so there's your few to try. Again, pause the video. Answers will be coming up shortly. There's the answers to those. 3 times the square root of x, y to the 5th times the square root of 5, and 3 times the cube root of x squared. Okay, this is where they start to get interesting. So, up to this point, either you could take the square root or you couldn't, and if you couldn't, you just left it in the radical. The reason why that is because the things we left in the radicals couldn't be simplified any further at all. That's not the case here. So while we can't take the square root of 12, we can use the product rule to break down 12 into 4 times 3. I can take the square root of 4, that's 2. And of course, I can't take the square root of 3, so I just leave that in the radical. We know we're finished when the thing in the radical can't be simplified any further, or it can't be broken down into factors that simplify. So you've got to think about the factors of the number in the radical. Next one is the cube root of 54. This is where it gets really interesting. Can't take the cube root of 54, but I can break 54 down into a couple of factors. How about 9 and 6? Will that work? Can't take the cube root of 9 and can't take the cube root of 6. So that won't work. Let's think about this one for a second. What other factors of 54 are there? There's 1 and 54. Of course, that doesn't work. There's 2 and 27. Can I take the cube root of 27? 3 times 3 is 9. 9 times 3 is 27. There it is. So 27 and 2. Cube root of 27 is 3 times the cube root of 2. So these are very similar to the factoring ones. You've got to think about factors. You've got to think about different factors. And you've got to think about the ones that you can simplify. It may take some guessing and checking like I just did there. Example C, 4th root of 80. By the way, little shortcut. Anytime you have 4th roots, you're looking for things that will probably simplify to either 2 or 3. So 4th root of what is 2? 4th root of 16. So is 16 times something 80? 16 times 5 is 80, right? 4th root of 16 is 2. 2 times the 4th root of 5. You may take a minute to think about that one. You may even rewind this video and listen to me explain that one more time. It may help. Fifth root of 64, again, fifth root of what is 2? The fifth root of what is 2? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. 32 times something, 64? Do 64 divided by 32. You should get what? Sorry, I had to pause the video and cough. I was saying 64 divided by 2 is 32, right? Yeah. So how about the fifth root of 32 and the fifth root of 2? Fifth root of 32 is, of course, 2. So it's 2 times the fifth root of 2. Again, pause the video, think about this, go back, listen to it again. I think it'll make sense to you after that. And then, of course, you get to try some. These are the last ones for this video. Again, think about breaking them down into their factors, into their parts. Pause the video now, and I'll put the answers up in just a second. All right, there's your answers. Take a look at the second steps there. Make sure you understand how those are broken down. Again, when you see higher powers, higher roots, rather, you're looking for things that simplify into 3s and 2s, okay? So if that should help. You won't see any cubed roots or fourth roots or any fifth roots, anything like that you have to simplify, that simplify to anything bigger than 2 or 3 99% of the time, okay? So just think about that as you're moving forward. And that's going to be it for this one. This will get you through, like I said, section 7.1, which will be homework 18. You'll also see the information up there for homework 19. That's coming up next.